Okay, so this is a quick review for module 11. We're gonna be doing equations and inequalities. So, well, we actually already did. So this is just to see, we're writing the equations and we're gonna just check to see if the answer actually goes in there. So we're gonna see if that is actually a solution for that equation, and the only thing I have to do is whatever I'm given, I'm gonna put it right here and see if that's true. Is it true that 54 divided by 7 equals 8? 7 times 7 is 49, so that will give me 5 left. So no, because if I do inverse operation without even looking at that, 7 times 7 is 49. So that would be that's actually wrong, because it will have to be 56. So this is not a solution for that. Okay, x is actually 56, because 56 divided by 7 is 56 divided by 7 is 8. But you only have to say no and why. This one right here, I'm gonna plug that in here. Remember, it's not 39, but 3 times 9. Is it true that it's 27? And I go 27 equals 27. Yep, it works. So this one actually is the solution for that. Okay. For 11.2, we're gonna we are doing adding and subtracting equations. So basically, we're trying to solve by doing the inverse operation. Remember, whenever you see a minus, you have to do a plus, and whenever you see a plus, you're going to have to do a minus, because you want to move this one to the other side, this term to the other side of the equation to isolate your variable. Okay, always remember inverse operation. And what you do to one side, you do to the other side. So in this case, because I'm subtracting 13, I have to add 13 on both sides. That way I don't change anything. So that cancels out. I bring down my q equals, and then I go, okay, so this one right here, I meant to be tricky. So if you have it like this, that is wrong, because that's 1.3. Okay. Remember, a whole number has a decimal at the very end, so I have to match the decimal. So I have here, that's what I have. Okay, so always whole numbers have a decimal at the very end. So when I add those together, I get 33.7, and that will be my answer. And I can go back in here and plug it in and say, is it true that 33.7 minus 13, again, remember 13 has a decimal right there, gives me, yep, 20.7. In case you forgot and you didn't move your decimal where it was supposed to go, and you have something like this, and you end up with 22, and then I say, okay, so true that 22 minus 13 equals that. And no, this is actually 9, and that is not equal. So then you can check that your answer is wrong by doing that. Okay, so always plug in your answer back in the original equation to check your answer. So here we go, your favorites. Fractions. So inverse operation of addition is subtraction. So I'm going to subtract 1/2 to both sides. This cancels out because that's just 0. Bring down my x equals, and then I have 2 1/4 minus 1/2. Remember, when you add or subtract fractions, you have to have the same denominator. In this case, we don't have the same one, so we have to find the LCD, the LCM. So the least common multiple between 4 and 2 is 4. This one's already in 4s, but this one is not. So I'm going to change that into 4s. What did I do to the 2 to make it to 4 multiplied by 2? What I do to bottom, I do to top, so that gives me 2/4. So now I have 2 1/4 minus 2/4. Now, some of you might be able to do it mentally. The ones that can, then you have to change this into an improper fraction. And how do we do that? We go 2 times 4 is 8 plus 1 is 9. So 9/4 minus 2/4. Once you have the same denominator, you just keep it the same, but you subtract the tops, the numerator. So 9 minus 2 is 7. And then I have to change it back into a mixed number. So again, many of us can do it mentally, but for those of us who need a little extra help, I go 7 divided by 4, that's 1 time. And I have a remainder of 3. This is my big whole number. And this is my remainder that goes right here. So 1 3/4. So x equals 1 3/4. And again, I can go back in here and plug it in and say, is it true? I'm going to use this spot right here. Is it true that 1 3/4 plus 1/2 equals that? And again, we know that this is 2/4. So that gives me 1 5/4. That's an improper number fraction. So I have to make that into, let's do this, into a mixed number. So 5/4 is basically 1 1/4. And then I have one more over here. That gives me 2 1/4. So yes, the answer is correct. Okay. Okay, last one. We're gonna write inequalities. So this one says Sebas needs at least important $5 to buy his mom a gift for her birthday. So at least, remember, we can either do greater than, less than, greater than or equal to, or less than or equal to. I'll come back to this one, I forgot it. So at least, so that means that $5 work, but it has to be at least $5, okay? So I can say X has to be at least $5, okay? It doesn't say more than $5. If I only say more than $5, then I wouldn't include the equal or equal to, but it says at least, so that means that 5 works. And so when I graph, I'm gonna have a closed circle because the 5 is actually included, and I'm gonna shade to the right because X is greater than or equal to 5, so numbers get bigger to the right of it, and I do that, and so I'm done with that one. This one says Olivia has fewer than 8 pretzels left to share. So fewer means less, so less than, and then 8. So again, when I graph, that's gonna be open circle at 8, and then it's less, and so I'm gonna shade to the left because numbers to the left of the number line get smaller. Okay, let's come to this one. So again, inverse operation. So right here, remember when you have a coefficient next to a variable, so basically a number next to a letter you're multiplying. So the opposite of multiplication is division. So I'm going to divide by 7 to isolate my x, and 7 divided by 7 is just 1. And what I do to one side, I do to the other side. So then I go first one in the house, so 10 and a half divided by 7. In this case, I just need to bring my decimal up. There's no decimals and my divisor, so I leave it alone. So that's 1 time, so that's minus 7, so that's 3, bring down to 5. How many times is 7 going to 35? That is 5, and so that is 35, and I'm done. And so I can say x equals 1 and a half. And then again, how do I check it? I need to go back in here and say is it true that 7 times 1.5 equals that. So let's check that. 7 times 5 is 35. Carry my 3 over. 7 times 1 is 10 plus 3 is 10. And then remember decimal point right here, 1 right there. Good. Okay, so that's that. And then for the next one, I'm dividing the x by 3. So x divided by 3. What's the opposite of division? Multiplication. So I multiply by 3. That cancels that. I multiply this by 3. So then I have 4 and a fifth times 3. I have to change this into, again, some of you can do it mentally. If you do the 3 times 4 and then add to whatever, you get 3 times 1/5. But I'm not going to try to confuse you. So I'm going to do it the long way. So I'm going to change this into an improper fraction. So remember, I go 5 times 4 is 20 plus 1 is 21 over 5. And to multiply by whole number, I put in 1 under it because it's just 3. 3 divided by 1 is 3. And then if there's anything to cross cancel, we'll do that. But there's nothing here. So I'm going to multiply straight across. So 21 times 3 is 63 divided by 5. See, I think the other way was easier, but I don't want to confuse any of you. So then I have to simplify, and then so I go 63 divided by 5. That's 1 time. I'm tempted to do it my way to save time, but okay, never mind. And so that's, oopsies, this is 2, sorry. So then I have 12 and 3/5, and that's my x. And again, to check it, I can go ahead and divide that by 3, but I'm not going to because I know for sure that 4 times 3 is 12. Let me show you the way that I was telling you. So can you agree that 4 1/5 equals 4 plus 1/5? So then I can use the surety property on this one. Look. The magic of math. And you go 3 times 4 is 12. It's actually the magic of the amazing brain that God gave us, that math shows us the beauty of patterns and all that. Anyways, and then 3 times that is 3/5, and I got the same answer, 12 and 3/5. See? Now you have different tools in your toolbox already. I'll see you later. Blessings. Study this up for your test and be ready. God bless you. Bye.